Welcome to Naveen Tech Hub.
Hey everyone, and welcome. Today, we're going to build a complete roadmap for data engineering system design from the ground up. If you're looking to understand how to architect robust, scalable data systems, well, you're in the right place. Let's get into it.
You know, the role of a data engineer is changing, and it's changing fast. With the explosion of AI and large language models, just moving data from point A to point B, that's not going to cut it anymore. As this quote says, the modern data engineer is really an architect, building systems that serve not just people, but intelligent AI agents.
And that's the big question, right? Where do you even start? Building these massive, complex systems can feel pretty overwhelming. But just like building anything great, it all starts with a solid blueprint. And that's exactly what we're going to give you today, a step-by-step map to guide you from the absolute basics all the way to advanced system design.
So here's our game plan. First, we'll talk about what it means to be an AI-ready data engineer. Then, we'll dive into the fundamentals with foundations and pipelines. After that, we'll level up to real-time systems and storage. Then, get into the really cool stuff with advanced design and infrastructure. And finally, we'll wrap up with how you can start your own journey with some hands-on projects.
So why is this so important right now? Well, it's because AI is incredibly hungry for good data. We're not just building simple pipelines anymore. We're designing entire platforms that can handle the massive speed and scale needed for things like generative AI. Your systems have to be AI ready from day one.
All right, let's start at the very beginning, stages 1 and 2. This is all about the fundamentals. You know, you can't build a skyscraper on a shaky foundation, and it's the exact same for data systems. We need to nail down how data flows, where it lives, and how we build the reliable pipelines that move it around.
Okay, one of the very first decisions you'll make is about your database. Think of SQL databases like a perfectly organized spreadsheet. Everything is structured with clear columns and rows. You have to define that structure before you put any data in. That's what schema on write means. On the flip side, you have no SQL databases. These are your go-to for messy, unstructured stuff like social media posts or sensor data because they're super flexible.
Now, let's talk about something that's absolutely critical in large systems: consistency. Imagine you update your profile picture. Consistency is the magic that guarantees your friends in New York and your friends in Tokyo both see the new picture at the same time. It's a huge challenge, but without it, things would get really chaotic fast.
This right here is the bread and butter of data engineering, often called ETL. First, you extract the raw data from all its different sources. Next comes the transform step. This is where you clean it up, reshape it, and get it into a useful format. And finally, you load it into its final destination, like a data warehouse, so it's ready for analysis.
So how do you manage all these pipelines? You use an orchestrator. Here are the big three. Think of Airflow as the seasoned veteran. It has a massive community and tons of integrations. Prefect is more like the sleek, modern newcomer, with a beautiful UI and a big focus on reliability. And then there's Dagster, which is a developer's dream because it's asset-aware. It actually understands the data your pipeline is creating, which makes testing way easier.
Okay, now that we've got our foundations, let's crank things up a notch. We're moving on to stages 3 and 4, where we introduce the need for speed with real-time systems and take a hard look at where all this data actually lives. For a long time, we processed data in big chunks or batches, maybe once a day. But think about it. Modern apps can't wait that long. Fraud detection needs to happen now. Live dashboards need to be, well, live. This has led to a massive shift towards streaming, where we process data continuously as it's created.
And these are the tools that make it all happen. You can think of it like a high-speed factory. Messaging systems like Kafka are the conveyor belts, bringing in a constant flow of raw data. Stream processors like Flink are the robotic arms, transforming that data on the fly. And real-time databases like Lakehouse are the final inspection station, analyzing everything as it comes off the line. So, where does all our clean, processed data end up? Well, for decades, the answer was the data warehouse. It's like a highly organized library built specifically for business analytics. All the data is structured, clean, and ready for generating reports.
But what about all the messy stuff? The images, the raw server logs, the audio files? That's where the data lake comes in. It's just a massive, affordable place to dump all of your data in its original raw format. This is an absolute playground for data scientists who want to explore everything without any restrictions.
So, do you have to pick one or the other? The structure of the warehouse or the flexibility of the lake? Not anymore. The modern solution is the data lakehouse, which basically tries to give you the best of both worlds. It brings all those nice, structured features of a warehouse directly to the raw data sitting in your lake. And this table just lays it all out perfectly. You can see the warehouse is for business analysts working with structured data, the lake is for data scientists exploring raw data, and the lakehouse, it's trying to be the one-stop shop for everybody. The technologies listed here, Redshift, S3, Delta Lake, these are the absolute titans in the industry.
All right, time to put on our architect hats. We're moving into the really advanced stuff now. This is where you stop just building pipelines and start designing entire end-to-end systems. We're talking high-level patterns and the infrastructure that powers it all.
Two really famous patterns you'll hear about are Lambda and Kappa. Lambda is the older approach. It uses two separate paths for data, a slow, super-accurate batch layer and a fast, real-time speed layer. Kappa architecture comes along and says, wait, why do we need two systems? It argues you can do everything with one powerful streaming pipeline. It's much simpler, but you need really good streaming tools to pull it off.
Now here's something you absolutely have to understand about modern data systems. They are defined by code. We use Docker to package our applications into these neat little boxes called containers. Then we use Kubernetes to manage thousands of those containers. We use Terraform to write code that literally builds our cloud infrastructure for us. And CI/CD pipelines automate the whole thing, from code check-in to deployment.
Okay, we've talked the talk. Now it's time to walk the walk. We've covered a ton of theory, but the most important stage is turning all that knowledge into actual skill. And really, there's only one way to do that. You have to build things. Here's a perfect place to start. Build a classic batch pipeline. You can use Airflow to schedule it, Spark to do all the heavy lifting and transformations, and then load your clean data into a warehouse like Redshift. This project will make those first couple of stages we talked about really sink in.
Ready for a bigger challenge? Try building a real-time pipeline. You could simulate website click data, for example. Use Kafka to grab every click, use Spark Streaming to analyze it on the fly, and then feed those results into a fast database like ClickHouse to power a live dashboard. This is where you really put stages 3 and 4 into practice.
And of course, your learning journey never really stops. If you want to go deeper, there are some amazing courses out there on platforms like these. Seriously, check them out. Read the official docs for these tools and find some good data engineering blogs to follow. It's the best way to keep your skills sharp.
And that brings us to the end of our roadmap. We've laid out the path, from the basic building blocks to complex architecture. So the only question left is, what data-intensive system will you design first? If you want to learn how to build real-world AI systems, covering data engineering, AI architectures, and scalable systems, subscribe to Naveen Tech Hub. We don't just learn tech,